started briefly, and we defined the surface as some finite region of object, right? Really finite region of object with some finite thickness. And the way to think about it is that you have a three-dimensional object like this, and you have layer structure. And then these layer, of course, each of these layer have two-dimensional periodicity, xy periodicity. And then in the z direction, in the depth direction, if you like, the spacing of these are not necessarily the same. So when you change from the first layer to the second layer and then the third layer, the spacing oftentimes may change. Usually change up to 3 layers, but there could be exception to this. So beyond the third layer, normally the spacing then become the same. And at that point, we call this, we have reached the bulk area. Okay. So in addition to this, I say that this layer, two-dimensional layer, has 2D periodicity. That is true. However, the 2D periodicity may not be the same as the bulk 2D periodicity in here. And this is known as lateral reconstruction. So there's both in the depth direction, in the reconstruction in the depth direction, and also in the lateral direction, whereby the atom can move from the both xy position. Okay, so that's a couple of points to bear in mind. That is because due to the fact that you terminate your bulk surface at that point, and the atom has to readjust to find its lowest minimum energy point in order to counter this termination of the bulk in 3 dimensions. Okay, so that's something that right away we notice. Reconstruction, surface reconstruction will occur in most cases in the case of a surface. Okay, so we define a region with finite thickness with no periodicity in the direction normal to the surface in the depth direction. That's what I meant by depth direction. And then the region, when you got to this region, right, got to the region, there's no change in the bulk direction, then you have reached the so-called bulk. And sometimes this is often called a substrate. It's a bit of a misnomer because certainly the surface itself is also a substrate, depending on who you talk to. If you talk to a film guy, they would say substrate with the understanding everything here, including the self-edge is a substrate. So there's a little bit of jargon inconsistency depending on who you talk to. And then we'll start, what we want to do is that we first start talking about the bulk area first as our reference point, because it has 3D periodicity, and I am counting on hoping people may have some background in solid state chemistry or solid state physics to know about this, about the background on the bulk. And of course, to determine the bulk, and in looking at the surface structure of the bulk, we are talking about some basic thing, such as crystal structure, diffraction, residual lattice, and Brillouin. So 4 topics, basically 4 topics that I just want to hopefully remind people and what they have seen. If not, then this thing is not so difficult to know about. We would not do X-ray diffraction type question, you know, so it's okay as long as we are aware of how the terminology in these fields. Okay, and then from this point of reference, we can then move on to discuss the structure of this finite region of space in here, this self-edge, so-called self-edge region, to realize what is the surface structure. So what is the changes in the surface structure, in particular reconstruction that I mentioned earlier on. Okay, surface reconstruction, a big deal in surface chemistry. Okay, and then I mentioned a couple of things here that if you go from 3D to 2D in some way is simpler, but in another way is more complex because of this reconstruction and loss in symmetry in the third direction. And so, and when we talk about surface reconstruction and surface structure, we will use electron diffraction as a primary technique to probe, if you like, the surface structure itself. Okay, so very quickly then, we want to give you a quick rundown of what is the bulk crystallography of the bulk, and in particular crystal structure, and then we will then talk about other things from the surface two-dimensional periodicity. Okay, so we're talking about 3D periodicity, meaning that there's no variation in the D spacing, in this so-called D spacing between layer. When we are talking about the bulk, it means that we have reached the region whereby no change is observed, and that's what the bulk region, and then this is the surface region or cell bank region. Okay, and then to think about this, we can define a few things. Okay, so I let you pick the best reference book you want, because there's many references about these bonding structure, particularly in solid state chemistry book or inorganic chemistry book, that most of us may have seen already in our undergraduate curriculum, or solid state physics book as well too, like a few common ones that you may see in undergraduate curriculum. They would normally define some of these. If you're not comfortable with it, then go read one or two chapters in some of these textbooks, and you should be fine. Okay, so what we want to do then is that, what is first of all crystal structure? Crystal structure is defined, of course, very generically. We define crystal structure as a periodic 3D array of atoms, right, or object, if you like. It could be a molecule as well, not necessarily atom. But in this case, we think very simply them as atoms. And this 3D array, of course, is known as the lattice. And each of these lattices consists of a unit cell, right? This unit cell build up the entire lattice. So this is rather fundamental stuff that we are familiar with. And then we also learn, probably in undergraduate curriculum, we know about these. We would have a course in symmetry, and usually they talk about point group symmetry. And I'll just remind you what they are. Symmetry element and operations, right? Symmetry element and operations. So you have, there are many types of this symmetry operation. In the case of, and in the case of point group, there are 5 of these, and they are, just very quickly, identity rotation, refraction, inversion, and improper rotation, right? So if you don't know, I think this is all obvious, but if you don't remember what improper rotation is, it means that you rotate by 360 divided by n, and then you do a refraction. So that's an improper rotation. Okay. So that's what improper rotation is. Sometimes people may not remember what that is. So there are 5 for point group. There are 5 such general operations. They are symmetry operations. Symmetry operations are operations that you can change, operate on your system, and then after the end of the operation, you do not see a effect of the change. From these symmetry operations, you could generate something called point group, right? Point group is another thing that people talk about. There are not so many point groups. There are all